Good morning, students. Today we are going to see graphing functions using transformation. What is graph? Plotting x point and y point in your axis, right? So in your lower classes we plotted points in the graph and then we join the dotted lines, right? Then why we are using graph? Yes, a graph will help us more than its analytical expression, right? So it is easy to understand while seeing the graph. Is it easy to understand, right? Okay. Can you able to draw graph quickly without plotting many points? No, because by plotting the points only we can able to draw, right? But after knowing this concept, graphing function using transformation, after know this concept, definite without plotting many points, you can able to draw a graph. Is that clear? So what is graphing function using transformation? When we use transformation, we no need to plot many points in the graph. So by using the concept, we can draw the graph. That is your transformation. Graphing using transformation. So here we have three types of transformation. One is your reflection, translation, dilation, right? So using this three concept, we can draw the graph. So first, reflection. Reflecting. What does mean by reflecting? It reflects as, right? So mirror image. You can say it is a mirror image. Okay. So the reflection of a graph of a function is the graph that is symmetric to it with respect to a. Actually, reflection means mirror image of the graph. So mirror image of the graph, what we are getting is your reflection. So when you can use reflection is when y equal to f of minus x, y equal to minus f of x, y equal to f inverse of x. When these three functions are there, you can use the reflection topic. So reflection is nothing but mirror image of the graph. That's all. And while explain with an example, is it easy to understand? But just know what is reflection, mirror image of the graph. Okay, so these are the points when you can use reflection. Next is your translation. So what is translation now? A translation of a graph is a vertical or a horizontal shift of the graph. So you can move the graph vertically or horizontally. Okay, that produces congruent graphs. So translation is nothing but a graph is a vertical or horizontal shift of the graph. So translation means what? Move your graph vertically or horizontally. Is that okay? Now, we have translation. We have 4 points to remember. That is, you can move the graph left, you can move the graph right, you can move the graph upward, or you can move the graph downward. Okay, now always how can you denote function? Y equal to f of x, right? Y equal to f of x is the function. So we draw the graph for y equal to f of x. Now if you add any constant inside the function, so f of x is your function. If you add any constant inside the function, then you have to move the graph left side. If you subtract any constant inside the function, then you have to move the graph right side. Okay, now f of x is your function. If you add a constant to the function, you have to move the graph upward. If you subtract the constant with the function, then you have to move the graph downward, right? Add constant with function left, subtract with the function right. Add constant outside of function upward, subtract constant outside of function, you have to move the graph downward. This is your translation. These 4 points, you have to keep it in your mind. Next, dilation. So when you can use, what is dilation actually? So dilation is also a transformation which causes the curve stretches or compress. So the diagram may be stretched or it may be compressed. That is your dilation. Okay. So in dilation we have 2 points to remember. That is, if the positive constant is greater than 1, the graph moves away from the x-axis. So if the positive constant greater than 1, that graph moves away from x-axis. If the positive constant is less than 1, the graph moves towards the x-axis. Greater than 1, away from the x-axis. Less than 1, that is constant less than 1, graph moves towards the x-axis. So here 4 points, here 2 points, here 3 points you have to remember, right? So translation, 4 points are there. Dilation, 2 points are there. Reflection, these 3 points are there. So if you know this clearly, then you can proceed the problem easily. Now I'll explain with an example. So first I'm going to take the function f of x equal to mod x. What is mean by mod x? Mod means only positive value, right? So we are taking f of x equal to mod x. So what is your function? F of x, we can take it as y also, right? So y equal to mod x. For mod x we have to draw the graph. Y equal to mod x, we have to draw the graph. Have to draw the graph, we have to take x point and y points. So if I take x equal to minus 2, modulus of minus 2 is what? 2. So your y value is 2. If I take x equal to minus 1, what is mod of minus 1? It is 1. So y value is 1. When you take x is 0, y also 0. x1, y also 1. x2, y also 2. Correct? So that y equal to mod x, we are going to plot it in the graph, right? Okay. So how can we draw minus 2 comma 2 here? Minus 1 comma 1 here. 0 comma 0. 1 comma 1. 2 comma 2. Is that right? So after that you have to join the line, right? So graph will be like this. So this is what? This is your graph, y equal to mod x. Is that right? Okay. Next, see this question. F of x equal to mod x minus 1. So what is mean by f of x equal to mod x minus 1? Look at here. This is your question. It is given that f of x equal to mod x. Now we are subtracting constant inside the function, correct? Mod x minus 1 means with this function inside, that is inside the modulus, we subtracted 1. So if we add or subtract inside the function, what you have to do? Move left or right. In subtraction kuduthanaala, you have to move the graph right. Correct? Okay. Now look at here. Move the right to 1 point, we have to move, right? So y equal to, for this one, y equal to mod x minus 1, I have to move 1 point to my right hand side, that is here. Correct? 1 point to my right hand side. So this one. So how can I draw the graph? So here, from here I have to take like this and like this. See, without plotting the points, using the transformation, I have drawn the graph. So this is your y equal to mod x minus 1. Is that clear? Okay, one more example. Y f of x equal to mod x plus 1. So now look, tell me, is that I add constant inside the function or outside the function? Yes, it is inside, because mod kulla I have added, right? So since I have added inside the mod, so I have to move this original graph. This is your original graph, right? 1 point left to the given graph. So this is your original graph. In the 1 point left I have to move. So if I have to move left now, this is that 1 point, right? So how can I draw the graph? I have to draw like this, from here to 1 and here like this. So this is your function y equal to mod x plus 1. Is that clear? So actually for one function only we have plotted points. After this, these two functions, using your transformation, we did the graph without plotting the points, right? Okay, same thing. One more example also I'll tell you. So same y equal to mod x will come here. It touches the 0, right? So this is your y equal to mod x, right? Is that clear? Now your question is f of x equal to mod x minus 1. Now see here, what is our original function? Y equal to mod f of mod f of x. Y equal to mod x is your original function. Now I have subtracted one number outside of the function. Mod x is a function, so I have subtracted constant to the outside of the function. So if I subtract any constant outside of the function, what I have to do? I have to move 1 point down, that is downwards, right? So downward 1 point, graph, that is point, will come here. So see, I have to draw like this. This is what? Y equal to mod x minus 1. Is that clear? Okay, one more example. F of x equal to mod x plus 1. So mod x plus 1 means I have added one number, right? I have added one number outside of the function. Mod x is the original function. So adhoda I have added plus 1 outside of the function. So what I have to do outside? I have to move upward 1 point. So you have to move upward 1 point now here. So the graph will be like this. This is your y equal to mod x plus 1. Is that clear? Okay, one more time look at this, all 4 examples. What is this? This is mod x minus 1, right? So y equal to mod x is the original function. Y equal to mod x is the original function. So for that we have drawn like this graph. So if I subtract 1 point inside the function, you have to move right. Add 1, you have to move left. Add 1 outside of the function, move up. Subtract 1 outside of the function, move downward 1 point. Is that clear? So shall we get into the exercise? Now take your exercise 1.4. So 1.4, first problem. For the curve y equal to x cube in figure, try to draw some subdivisions are there given. So here, first question, it is given that y equal to x cube, right? Okay, for this function, how to draw the graph? So we can take x point, y point. So when you give x equal to minus 1 the whole cube is minus 1. So y equal to y also minus 1. X is 0 na, y also 0. X 1 na, y 1. X 2 na, y is equal to 8. So minus 1 comma 1, 0 comma 0, 1 comma 1, 2 comma 8, minus 2 comma 8, somewhere like that. So you will get graph like this. Is that clear? Okay, so now using this graph, many subdivisions are there. So using transformation, we are going to see how to do the remaining problem. Okay, so first we can take the solution. And your first subdivision, it is given that y equal to minus x cube. So y equal to x cube is your function. Y equal to minus x cube. So if minus add to the function, we have to use a reflection graph. That is, I told you, no, reflection. Yeah, that reflection graph we have to use. So hereafter, no need to plot these points and all. Directly you can use the types of transformation and you can draw the graph. So since it is y equal to minus comes in front of the function, this is reflection. What is this type? Reflection. So reflection means what? Mirror image of the graph. What does mean by mirror image? That will see in opposite direction. When you show it in the graph, it will show. When you show it in the mirror, it will given you the image as opposite direction, right? So look at here. I'm going to draw. So this is your x-axis, y-axis. 1, 2, 3. And this is your minus 1, minus 2, minus 3. 1, 2, 3. Minus 1, minus 2, minus 3. Is that right? 1, 2, 3. Okay. Here, your image y equal to x cube is like this. So, mirror image, na, the graph will be in opposite direction. So, this will come like this. That's all. So, you will get here 1 point, here 1 point, here 1 point. So, how can you write that one? You can add like this, it will go off, and this is also like this. This is your y equal to minus x cube. Is that okay? So since the question it is minus, we have to take it in the mirror image. Mirror image means opposite to the given direction. So given direction is like this. So we have to take it in the opposite direction. That's all. No need to plot the graphs and all. Okay. So here, since y equal to minus f of x, this is the reflection, correct? This is your reflection type. So this is the reflection of the graph of f about the x-axis. That's all. Is that clear? So since it is the reflection of the graph of f about the x-axis. And your second subdivision, y equal to x cube plus 1. Actually, what is the given function y equal to x cube? So x cube order, we have added one constant, correct? So here we can write here, since y equal to f of x plus 1. This is a format like this. No, x cube is your f of x. Although we have added 1. So this is the graph of f of x of f. Okay, we have to shift to the upward. Why upward? See your translation that 4 types for 1 unit. Why we are moving upward? Because if we add constant outside of the function, we have to move upward, right? So for that only we have move 1 point upward. So we can draw x-axis, y-axis, and 0, 1, 2. Sorry, 1, 2, 3. This is your 0. Minus 1, minus 2. 1, 2. Minus 1, minus 2. Now look at here. This is your graph, right? Y equal to x cube. This is your graph, y equal to x cube. So y equal to x cube, what we are going to do? We are going to move 1 point. See, y equal to x cube. Since we added a constant to the function, we have to add move upward. We have to move the graph upward 1 unit. So how can we move? This is your first point, right? So the graph will be here. So the graph will be like this. This is your y equal to x cube plus 1. Is that clear? Y equal to x cube plus 1. Okay, next, third subdivision. So what is your third subdivision given? Y equal to x cube minus 1. So x cube equal to minus 1, how can we write? Since y equal to f of x minus 1, this is the graph of f shifts to, how have to shift to the downward. Why we are shift to downward? If we subtract 1 unit, we have to 1 unit to the function, we have to shift downward. So downward for 1 unit. Is that clear? Now, so if we want to draw the graph, again same thing, x-axis, y-axis. So z 1 2 3, minus 1 minus 2, 0 1 2, minus 1 minus 2. Now I have to move the graph 1 point down. Okay, so this graph will be like this. This is your y equal to, is that clear? So this is your y equal to x cube minus 1. Is that clear? Yes. So your next subdivision, fourth subdivision. So what is your question? Y equal to x plus 1 the whole cube. Now tell me, see, actually x cube is the function. So inside the function we are adding 1 point. So inside the function, if we add 1 point, what we have to do? Shift to the left. Correct? Shift to the left. So how can we write here? Since y equal to f of x plus 1, okay, x plus 1 the whole cube, this is the graph, this is the graph of f of x shifts to the left for 1 unit, left for 1 unit. So we have to now, we have to move the graph left for 1 unit. Now left for 1 unit, again same, you have to draw your x-axis, y-axis. So 1 2, minus 1 minus 2, 1 2, minus 1 minus 2, 0. Now we have to move 1 point left. Left means this point, right? So here, so the graph will be like this. This is your y equal to x plus 1 the whole cube. Hope you understand what is graphing using transformation. So transformation, how can we transfer? Using reflection, using translation, or using dilation. Is that clear? Okay. So let's take your second problem. Again, what is second problem? Here the curve is given as y equal to x power 1 by 3. Okay, and it is the problem, graph is also given in the problem. So your second problem, question, it is given as y equal to x power 1 by 3, right? Okay, so first, for the first graph we can plot the points x and y. When you take x equal to 0, y is also 0. When you take x equal to 8, so here 8 and 8 can be taken as 2 power 3, right? So that 3, this 3 will get cancelled, so y value is 2. Similarly, if you take x equal to minus 8, you will get y equal to minus 2. Now plot the points, your x-axis, y-axis. X you can take it as 2 4 6 8, minus 2 4 6 8. So 0 comma 0 and 8 comma 2 minus 8 comma minus 2. Okay, so if we join the points, you will get like this. like this. Okay, now your first subdivision. What is your first subdivision is given? So when you see the solution, solution. What is the first subdivision? It is given in your book. Y equal to minus x power 1 by 3. So minus x power 1 by 3 is what? We have to show. This is a reflection. Minus means reflection. Correct? So here we can take your x-axis, y-axis. So same point. Whatever the scale you are taking here, same thing you have to take. So 2, 4, 6, 8. Similarly here also. Minus 2, minus 4, minus 6, minus 8, minus 1, minus 2, 1 and 2. So the graph is like this. So reflection, how this will be? It will be like this. This is your y equal to minus x power 1 by 3. Is that clear? So how can we write here? Since y equal to minus x1 by 3 is the reflection, correct? Reflection of the graph of y equal to x power 1 by 3 about the x-axis. Is that clear? Okay. And your second subdivision. What is your second subdivision? Y equal to x power 1 by 3 plus 1. So x power 1 by 3 plus 1. Outside the function we are adding. So outside the function if we are adding, what we have to do? We have to move upward. Correct? So here first we can write the sentence. So since y equal to x power 1 by 3 plus 1 is the graph of f shifts to the upward for 1 unit. Now we can draw the graph. So your 2, 4, 6, 8, 2, 4, 6, 8, 1, 2, 3, minus 1, 2, 3, 0. So minus 1, 2. Correct? Okay. So we have to move upward. Correct? We have to move upward. So upward na here. So your diagram will be like this. Move upward. So this is your y equal to x power 1 by 3 plus 1. Is that easy? Is it clear? Yeah. What is your third subdivision? Y equal to x power 1 by 3 minus 1. Here also, since y equal to x power 1 by 3 minus 1 is the graph of f, right? Graph of f shifts to the what? Yes, downward. So subtract now, we have to move downward, right? So downward for 1 unit. So now we have to draw the graph. So this is your x-axis, y-axis. So same point, 2, 4, 6, minus 2, minus 4, minus 6, right? 1, 2, minus 1, minus 2. So actually it passes through 0, 0. So we have to move downward for 1 unit. So downward now, here it will come. So diagram will be like this. This is your y equal to x power 1 by 3 minus 1. Clear? Now, what is your fourth subdivision? Y equal to x plus 1 the whole power 1 by 3. So, inside the function, we are adding 1 unit. Correct? Huh? So, how can we write? Since y equal to x plus 1 whole power 1 by 3 cos the graph of f shifts to the left for 1 unit. So we have to move left, right? We have to move left for 1 unit. So take your x-axis, y-axis, 2, 4, 6, minus 2, minus 4, minus 6, 1, 2, minus 1, minus 2. So this is your 0, right? So we have to move left for 1 unit. So 1 unit na graph will like this, okay? So you have to draw like this. This is your y equal to x plus 1 the whole power 1 by 3. So hope you all understand what is this graphing function using transformation. Is it, children? That's all today's class. Thank you, students.